Dear students, today I will discuss with you some points from the chapter Chemical Energetics. First point, the SI unit of caloric value is kilojoule per gram. You should not think it is kilojoule per mole. Okay, it is only kilojoule per gram. Mind it. Okay. But whenever you consider the enthalpy of formation, enthalpy of combustion like this, you will take kilojoule per mole. Okay? Yes. In different types of enthalpies, we are used per mole. But for enthalpy of neutralization, we used gram equivalent, per gram equivalent. This is the difference. In other enthalpies, it is per mole. But for neutralization, it is gram equal per gram equivalent. Okay. Next. So example, enthalpy of formation is expressed in kilojoule per mole, but an caloric value is expressed in kilojoule per gram. Next point. For strong acids and strong bases, the enthalpy of neutralization value is minus 57.1 kilojoule. It is the exothermic reaction, therefore delta H is negative, that is minus 57.1 kilojoule. So value is 57.1. Okay, but if you change the strength of acid and base, okay, then the value decreases from 57.1 kilojoule. It will be 55, 54 like this. Okay, yes. Enthalpy of fusion. Enthalpy. What is enthalpy of fusion? Enthalpy of fusion is the enthalpy, the heat change, the heat required when 1 mole of the substance it changes its states from the solid to liquid state at its melting point. Okay, so mathematically enthalpy of fusion is equal to molecular mass multiplied latent heat of fusion per gram. Okay, so for ice it is 6 kilojoule per mole. Then what is enthalpy of evaporation? Enthalpy of evaporation at its boiling point. It is at its fusion is at its melting point, and this is at its boiling point. So mathematically enthalpy of evaporation is equal to molecular mass multiplied latent heat of evaporation per gram. Okay, so for water, the boiling point is 100 degrees centigrade. The enthalpy of evaporation is 40.79 kilojoule per mole. Okay, next, heat capacity of a system. What is heat capacity of a system? Capacity, you remember what is capacity? Capacity means the amount of heat required to rise the temperature 1 degree centigrade. So dq by dt, C is equal to dq by dt. Okay, so specific heat capacity at constant pressure, specific heat capacity at constant pressure, it is delta H by delta T. Similarly, specific heat capacity at constant volume, delta E by delta T. We will correlate these two. At constant volume, what is happening? Delta H is equal to delta E plus P delta V. It is the relation between enthalpy and internal energy. But at constant volume, what happens? Delta V becomes 0. So 0 multiplied P, this is 0. So you will get delta H is equal to delta E. But at constant pressure, delta H is equal to delta E plus P delta V. It will not be 0. Okay, so Cp minus Cb is equal to delta H by delta T minus delta E by delta T for delta E. Okay, so delta H, for delta H you put this one. When you put this one, delta E minus delta E cancel, P delta V will remain. So Pb is equal to RT, we know. So Cp minus Cb is equal to R delta T by delta T. So delta T cancel. You will get Cp minus Cv is equal to R. Okay. So why Cp is greater? Why Cp is greater than Cv? Because heat absorbed at constant pressure is utilized in two ways. Understand? Heat absorbed at constant pressure is utilized in two ways. One, in increasing internal energy, and second, performing work done. Okay, you see the relation Cp at Cp. What is Cp? Delta H is equal to delta E plus P delta P. So one part utilized for the increasing the internal energy, other part used for the work done. So therefore Cp is greater than Cv. Next, heat absorbed by a system Q is equal to, for problem solving, ms theta. Sometimes questions are asked. Let us take some amount of 50 gram of water at 0 degree centigrade, and you add 100 gram of ice at minus 4 degree centigrade. Then the total solution temperature will be what? Some like these questions are asked. So for this type of questions, this relation you have to use. Q is equal to ms theta. M is the mass of the substance, S is the your what? Specific heat, and theta is the temperature, rise in temperature. Suppose 10 to 0 degree or 0 degree to 10 degree. So difference is 10. So in this it is used. Next, specific heat capacity. What is specific capacity? CS is equal to heat capacity by mass. Heat capacity by mass. Heat capacity joule Kelvin inverse, mass gram inverse. Okay. Then molar heat capacity CV, specific heat capacity multiplied molar mass. Okay. Next is Kirchhoff's law. What is Kirchhoff's law? You see, if delta H1 and delta H2 are enthalpies of reaction at temperature T1 and T2 respectively, that means two temperatures are given at two different heat respectively, and delta Cp is the difference in heat capacities of products and reactants at constant pressure, then Cp delta Cp is equal to delta H2 minus delta H1 by T2 minus T1. Understand? What is delta Cp? Heat capacity, difference in heat capacity of products and reactants. This is asked. Should not confuse. Cp is the difference in heat capacity of products and reactants at constant pressure. Then it is the relation. The heat difference has two different heats and two different temperatures. Okay, students. Next in video, I will explain one problem based on this Kirchhoff's law. Okay. Have a good day.